If the points in a scanogram of data lie close to or on the line, we say that the relevant variables are approximately linearly related. We also have model breakdown. Model breakdown occurs when a model yields prediction that does not make sense or is a bad approximation. So let's start off by doing a quick sketch. And let's do some basic plots. So random point locations, that is our scanogram. Does it look like it's approximately linearly related? It looks like it is. Most of the points are close to that line, agreed. So they're close enough that we can say they're linearly related, or approximately linearly related. Okay, so let's say we have in this case a balloon. And balloons typically go up, right? So notice that those are dots for balloon height. So it's the height versus time. Okay, so this balloon is increasing. It's a helium balloon going up, up, up. Okay, watch it go up. Keep in mind, we only took part of the data, not necessarily all of the data. And do notice, we can always make other linearly related lines that are somewhere between most of the dots, right? But the question is, are they the line of best fit? In other words, to your point of view, do they approximate all of the points close to it well enough? Or are there better options? See? Well, the two lines there might not be the best options. Do notice, in this case, probably the green line is the best option for this case. It has most of the points close to the line. So as close as you can get it to most of them. So it's your point of view in many cases. Do be aware of that. So model breakdown. Model breakdown could occur in the further portion of our graphing, or at least in this case our approximation. Notice that in the upper region, the balloons will probably stop rising eventually, right? And then they'll start falling. So that region may not make sense to it anymore, because we can't assume the balloon's going to go up forever. So that region becomes a model breakdown. So just imagine, whenever you're working on a particular graph, where could you have errors? Ask yourself, where could there be errors due to the graph or future portion of the graph, or even before? So before the beginning of the graph, could it have errors before? So in this case, we can't have negative time, right? So if I had an arrow going down and to the left, I would have a model breakdown down on the left side as well. So notice that balloon keeps sort of staying stable at that height, but then eventually it'll start falling. And once again, this region will not be described very well by this line, but at least the beginning of it, which is the one we care for this particular case scenario, would be definitely described by our data. So we can approximate a linear relation in this case. Agreed?